So, a Hamming code is an error correcting code, and it can also use for error detection. There are different types of Hamming codes, and here we'll be discussing about the 7-bit Hamming code. So, in a 7-bit Hamming code, uh, there are 7 bits which is given as P1, P2, D3, P4, D5, D6, D7. This is the 7-bit Hamming code. So here the P represents parity and D represents the data. So what is parity? Now parity means you have two types of parity. One is the even parity and the other is the odd parity. Okay, so if suppose you're transmitting a data through a channel with an even parity, then the number of ones in that data, including the parity bit, will be even. And if you are using odd parity and you're transmitting the data, then the number of bits in the data, including the parity bit, will be odd. So at the receiver end, in the case of an even parity, the received data should be even number of ones, should contain even number of ones. And in the case of odd parity, the received data should contain odd number of ones, including the parity bit. If that does not happen, then there is an error. So in a 7-bit Hamming code, this is the format which you should learn. So it is P1, P2 and P4 are the parity bits, and D3, D5, D6, D7 are the data bits. So 1, 2, 3, 4. 4 data bits and 3 parity bits. So here we are going to consider even parity. So if you are considering even parity, and if you want to if the question is about odd parity, you can just consider everything as odd. Okay, so suppose how do you set the parity bits? Okay, so how do you set the parity bit? That is, P1 is set to a 0 or 1 so that it establishes an even parity over the bits 1, 3, 5, 7. 1, 3, 5, 7 means P1, D3, D5 and D7. P1, D3, D5 and D7. And P2 is set to 0 or 1 over the even bits 2, 3, 6, 7. That is 2 is P2, 3 is D3, D6, D7. And P4 has 4, 5, 6, 7. 4, 5, 6, 7 is P4, D5, D6, D7. So this you should learn. You should know this and you should know this. How do you set the parity bits and what is the format, 7-bit format of the Hamming code? Okay. So let's consider an example. Say Okay, so let's consider an example. Say encode the data bits 1101 into the 7-bit Hamming code. Okay, so 1101 is the data bits. 1101 is the data bits means what? This is D3, D5, D6, D7. So when you write, it is P1, P2, D3, P4, D5, D6, D7, and D3 is 1, D5 is 1, D6, D7. This is what is given. Now we want to find out what is P1, P2 and P4. So for that, what you will do, P1. So consider P1, 1, 3, 5, 7 you have to see. So 1 you don't know, you are going to set that. So P1 you are going to consider 1, 3, 5, 7 bits. 3 is 1, 5, 1, 3, 5, 7. So 3, 5 is 1, 7 is 1. And then you have the P1. So all these bits P1, D3, D5, D7, considering all these bits, it should have even number of ones. So check whether D3, D5, D3, D5, D7. How many bits, how many ones do you have? So you have 3 ones. 3 ones is odd. So to make it even, if P1 is also 1, then you can make it even. So P1 should be 1. So it will be 1, 1, 1, 1. P1 is also 1. So 1, 3, 5, 7 if you consider, you have even number of ones. So P1 should be 1. Only then these 4 bits when you consider, it will be even in nature. So P2 if you consider, it is 2, 3, 6, 7. So 2 is P2 itself and 3, 6, 7 is 3, 6, 7. 3, 6, 7 is 101. So you have even number of ones. So if you consider P2 also, if you put 1 in P2, then the number of ones will be odd. If you put 0 in P2, then you have 2 ones, so it is even. P4 if you consider, you have to consider 4, 5, 6, 7 bits. So that will be 4 is P4, 5, 6, 7 is 5, 6, 7. So that is 101. Again P4 should be 0. So P1 should be 1, P2 should be 0, P4 should be 0. So your answer will be P1 is 1, P2 is 0, P4 is 0. So your final answer is this. So encode the data bits into 7-bit Hamming code means you first written the data bits, then found out how to set the parity bits, and you set the parity bits and then write it in the code. So this is your answer. Yes. Now another question is, you're given a 7-bit Hamming code. Decode the message assuming that at most a single error has occurred in each code word. So the question is 1001 001 0111 1110 0011011. So this is your question. Yes. So these are all 7 bits, 1 2 3 4 5 6 7, all 7 bits. So this is transmitted through a noisy channel. Decode the message assuming that at most a single error has occurred in each code word. Only one error can happen. Okay, so that is the assumption. So first set you're taking, that is 1001001. So that is P1, P2, D3, D4, sorry, P4, D5, D6, D7. Okay, so parity bits are also set like this. So you have to check whether there is any error or not. So for that, P1 it is 1357, so which is 1357, 1357. So you have odd number, even number of ones, 2 ones, so that is even, so that is no error. So you're considering a bit, say C1. Since there is no error, C1 is set to 0. Next you will consider P2, which is 2367. So that is 0, 30, 60 and 7 is 1. So here odd number of ones, so there is an error. You will set C2 equal to 1 since there it is a error. P3 will be 4567. So that is 1 0 0 1, no error because of even number of ones. So what is C3? C3 is 0. Okay, next the error word will be C3 C2 C1, C3 C2 C1. So that is 0 1 0. In this particular case, either way if you take it's the same number, but always take it from C3 to C1. Don't take it from C1 to C3. It is like this. Only then the answer will be correct. So this is binary. So that is 2 in decimal. So what should you do? You should complement the second bit from the left. So your question was 1001001. So complement the second bit from the left. This is left 1 2. So this should be complemented. So that becomes 11010001. So again if you take 2367, so 2 3 6 7, so that has become even. So here the error has changed. So that is just for checking. This is your answer. This is your answer. Right? So likewise you can do for each of these. These are just 4 questions, 4 different questions. So this is how you do. You can check for this, this and this separately. So 2 types of questions. One is set the parity bits. Another is you'll be given the 7-bit code and you have to decode it. That is find the error and then correct it. So this is finding the error and this is correcting it. Always take it from 3 to 1, not 1 to 3. Okay, so this don't forget, and then complement the bit which you get, which is equivalent to the decimal equivalent to the binary number. Okay, so that is how you do it. So these are the 2 questions which can come in Hamming code.